Welcome, guys. It is week 11. The two lessons we're looking at this week are lessons 106 and 107. So, 106, we're solving literal equations, transforming formulas, and working more with root values. Literal equation is an equation that contains letters instead of numbers. We can rearrange or transform these equations by using the rules that we have, inverse operations, different things like that. So we can solve it in terms of, we have three unknowns, x, a, or b. And so we're not going to solve for what x, a, or b is necessarily. We're just rewriting it in a way that we can use it. So if we had x plus a equals b, and we want to solve in terms of x or get x by itself, okay, just like if it's a number, this was plus 10, we would subtract 10. But it's plus a, so we're going to minus a from both sides. So we're going to have x equals b minus a. Again, we didn't solve for x or b or a, we just rewrite. It's the same thing when we have distance formula equals rate times time. Okay, rate times time, how fast we're going, how long we're traveling that will tell us how far we've gone. We could say our rate is our distance divided by our time. So it's just rewriting formulas and not necessarily solving, but using the same properties that we've used of inverse operations, isolating variables, to rewrite some of these formulas. Okay, ax equals b. If we want to be x, well, this is multiplication, so we need to divide both sides by a. X equals b over a. We use area equals length times width for solving formula of a rectangle. Well, let's say we know the area and the length, and we want to find the width, and we could do that by manipulating our equation. And we have a equals length times width, divide both sides by L. It's going to give us A divided by L equals W. And again, whether the X or the W or whatever we're trying to isolate ends up on the left or the right, it's an equal sign, so it can be on either. We usually write it on the left side just because we read in English left to right. It doesn't matter mathematically. All right, more on roots. Again, square roots, squaring, like x squared equals 25. But if we get equations that have exponents, especially if they're even, we're going to have to pay attention because we're going to have more than one solution. So let's take a look at. Let's say. Let's say we have something like this, 4x squared equals 16. Right, well, we want to get x by itself, so we're multiplying again, inverse operations. So we divide 4 over 4 just once, so we have x squared equals 16 divided by 4, which is 4. Now we get two solutions because, the square root of 4, square root of both sides, square root and square cancels out. That's the inverse operation, just like addition and subtraction and multiplication and division. So yes, x does equal 2, but it can also be negative 2. So if I put in negative 2 and square it, it's going to equal 4. Same thing with positive 2. So we actually get two solutions in some of these types of problems. That's a brand new thing. Other than that, it's everything we've been doing all year. Inverse operations, isolating the variable. Just we have to pay extra close attention now because, especially if we have an exponent, we may have a situation where we get more than one solution. Cubed root, again, this is something we haven't seen, but again, this little number in there. So we think what number to the power of 3 equals 64, and then we can do a cubed root. We can do a 4th root, 5th root, 6th root. So we've been typically just doing this radical sign, which indicates square root. We don't write in the 2, but it's implied. but we have other roots as well. We can actually do that on our calculator, so we clear out that. So if you go into math, and then I believe it's, yeah, the fourth option down there. So this fifth option is if we're doing something other than 2. So we know second x squared, this gives us just the square root. We go into math, we can do a cubed root, or this option 5, we can do a fourth root. Fifth root, we can even have that be a fraction in there, so we can put in really anything for x. If we want to do a cubed root with 64, we hit enter, and that's 4. So we could think of this in the other direction, where 4 to the power of 3 equals 64, so the cube root of 64 equals 4. 4 times 4 is 16, times 4 is 64. So the cube root of 64 is 4. And so that's something little new that we'll see a lot more down the road. So if we do the cube root of 1,000, well, what number to the power of 3 equals 1,000? 10. 10 times 10 times 10 is 1,000, so the cube root of 1,000 is 10. Now the cube root of 27, sorry, negative 27, sorry, negative 27, and it's negative 3. So since it's a cube root, we only get one solution. So not all exponents are going to give us more than one answer. So if we're saying what number to the power of 3 equals negative 27, it's not 3 and negative 3, because 3 to the power of 3 is positive 27. Negative 3 to the power of 3 is negative 27. So negative times a negative times a negative is a negative, or positive times a positive times a positive is, well, obviously a positive. So that's what we're doing right there. So if it's an even number exponent in one of those problems, we're going to have more than one solution. If it's odd, just kind of a note for down the road. All right. So again, you're going to math to do these. The examples we'll see today will probably work out to be whole numbers, which is good. So not too complex. But again, that's all that 3 means right there is a cube root. One number raised to the exponent of 3, or whatever number's in there, would equal this number. So that's how we go about solving those. Practice set, we'll do that when we get to class. Lesson 107 deals with slope. And I believe slope, there's some different notes of it on a reference sheet, point slope formula, slope intercept, slope of line. Probably won't get that complex with it this semester, but slope of something, you've probably been driving to Denver and you see those signs with the semi trucks on them showing a percentage. That is indicating a slope, because for how far you travel, you're going to drop a certain amount. If we are dropping faster versus slower, as a truck driver or whoever, you want to know that. Right? It's going to be very steep, because of the slope, you want to know that, versus it being a gradual incline or decline, it may not be as big of a deal. So if we look at number of yards to feet, okay, 1 yard is 3 feet, or feet to yards. If we flip the x and y axes, then it's 3 feet to 1 yard. So we see, depending on what our input and output is, it could be comparing the same two things, and it's going to affect the slope. Obviously, this one is a steeper slope than this one. And all slope is, and what was that right here? And slope, you can just remember, is just the rise over the run. And there's a way we can calculate the rise and the run based on 2 different points. But for right now, just remember rise over run. We'll be given a graph, and we can look at that and count. With these ones, if we're looking at if the slope is positive, negative, or 0, or cannot be determined, let's look at these. So if from left to right it's going up, it's a positive, and that you can see right there, because our slope is actually 1, is y equals mx plus b form in our linear formula. We have this, and m represents our slope. Why do we use m? I don't know. And then b is our y-intercept, or where we cross the y-axis. Okay, so if we have y equals 2x minus 3, well, this is a positive number, so our slope is positive. That's another way we can look at it. Or if we see the graph, we can pretty easily determine what the slope is, especially whether it's positive or negative. So we're going up from left to right, so that means it's positive. From right to left, we're going down. So again, we're thinking left to right. We're moving up, so this is a positive slope. It's a positive 1x minus 2, so that would be our slope. This one, we have no rise, so it's 0 over our run, which is really just continues on, 0 over 3, or 0 over 4, 0 over 5. 0 divided by anything is just 0. So this one doesn't have any slope. It's flat. If you're driving on a straight road and you're not going up or down, then it's no slope. It's 0. This one, from left to right, we're going down. If we were to move this over, we'd have to subtract x, so the slope would be -1. Okay? So our rise, again, we're dropping 1 as we go over 1, so the slope is -1. Okay? And from left to right, it's going down, so that's why it's a negative slope. This one is actually not a function because it doesn't pass the vertical line test because it is a vertical line. So x equals 3. This one is an undefined, or what we would say we cannot determine what the slope of this is. This one would actually give us a rise of 4, for example, a run of 0. Well, 4 divided by 0, rise over run, ends up we're dividing by 0, which we cannot do, so it's undefined. Okay, this is where it talks about the rise of run. Again, rise, whether we're going up or down, so the vertical movement, and then the run is the horizontal right or left movement that we have. So if we're moving left, negative. If we're moving right, it's positive. If we're moving up, our rise is positive. If we're moving down, it's negative. And it doesn't matter, we just need to pick 2 points. It's going to be the same slope whether we start at this point and go to this point, or if we start at this point and go to this point. So as long as we see the graph, that's what we're looking at. So rise over run, 3 over 2, 1.5 slope, or 3 halves. Okay, this one, rise of -1, run of 2, so -1/2 would be our slope. Okay, so slope is rise over run, 3 halves, and -1/2. So let's look at this one. The slope is 1 because I rise 1 and go over 1. Now let's say we went up 2 and over 2. Well, 2 over 2 is still 1. So it doesn't matter the points that we choose. If it goes through the origin, it's a pretty easy point to start at. Right? Well, let's say we accidentally went left. Well, -3, so rise of -1, 2, 3, a run of -1, 2, 3, and -3 over -3 is still 1. So it doesn't matter the direction you're going or which 2 points you choose. You just do the rise over the run, and that's going to tell you the slope. And it's going to be the same thing for the entire function. This one's -1. In my rise, I drop 1, so -1 over 1. -1 divided by 1 is -1. If we're looking at this one, I always try and find points that are go through the actual grid marks of the whole numbers. You don't have to do that, but obviously it's going to make it a lot easier than trying to figure out, oh, this point right here, what is that? Okay, so we have this point here and this one here. So let's see what our rise is. We go up 1, 2, and then over 1, 2, 3. So rise of 2, run of 3. So let's zoom out. 2 over 3. The rise of 2, run of 3, 2 over 3. Now we could have gone up 4 and over 6, but that would still reduce to 2 over 3. All right, we'll do the practice set together, and then we'll get to 108 and we'll return next week. So we'll see you guys in class.